opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We are always curious and seek opportunity. We have the spirit and insight to explore the moon, Mars, and beyond. But if rovers are to be the qualities of us as a race, we miss the most important thing: perseverance. We as humans evolved as creatures who could learn to adapt to any situation, no matter how harsh. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere. We, not as a nation, but as humans, will not give up. The human race will always persevere into the future. My name is Alexander Mather, and that's why I chose Perseverance as the name of NASA's next Mars rover. I don't really think that there is a word in any human language that can describe the feeling of having your name selected to be part of a mission from the greatest agency in the world, doing the most important things to help humanity spread to the stars. I am 13 years old, and I did not expect that I would be making any form of impact on human space exploration like this until I was at least out of college, or maybe in an internship. And here I am, and I just named the rover. Something I submitted was chosen by people who one day I plan to work with, and that's incredible. To me, perseverance means that in the inevitable setbacks that we're going to face on the main way to Mars, humans won't give up. Humans will keep on sending new missions, humans will keep on improving technologies, and humans will eventually live on other places throughout the solar system, and maybe even beyond. And that's just so important for all of our futures.
How do you nurture an idea, or shape it to solve problems, create opportunity, and open doors to a better life for all? First, find its strengths, discover its limits, refine it, test it, and repeat. At NASA's Langley Research Center, we strive to discover, distill, and connect great ideas, then channel them into solutions, leading to a brighter future. With vision and determination, we look beyond what's possible today and strive to make tomorrow a better place. An idea could be as small as a few lines of code, or as big as a revolutionary way to travel. It could be a system for building in the vacuum of space, or a laser that helps explorers land safely on the moon. We're on a quest to discover trailblazing ideas and transformative tools. We build, measure, and explore. We accelerate technologies and connect concepts, along with the people who envision them. And how we explore the universe. Our work will spread global goodwill, improve lives, and protect our planet. A great leap starts with just one idea. NASA Langley, where great ideas take flight.
Beyond the asteroid belt are fossils of planet formation, known as the Trojan asteroids. These primitive bodies share Jupiter's orbit in two vast swarms, leading and trailing the planet. Now, NASA is preparing to visit 7 asteroids. sphere odyssey that will span Jupiter's orbit. One mission will explore these objects for the first time. Lucy, the first mission to the Trojan asteroids.
The famous Italian monk Giordano Bruno in 1586 published a book in which he said the sun is a star and that the earth was a planet and that other stars certainly had planetary systems and probably even had life. And for that and other radical things that he said, the church burned him publicly. You could say that extrasolar planets was a much hotter field back then.
Exoplanets were almost as silly as looking for extraterrestrials, little green men on other planets.
Seriously, looking for planets was a kind of weird topic. The whole field had sort of a snake oil sheen about it because over the previous 50 years or so, there have been many, many claims of the first extrasolar planet ever, and the one thing all those claims had in common was that they were wrong.
California, astronomers Jeff Marcy and Paul Butler were quietly looking for Doppler shifts, changes in the observed color of light from the star.
I literally spent the first 8 years of the program simply trying to improve the techniques involved in making these sort of measurements, mostly totally under the radar. Nobody knew what we were doing and nobody cared.
A ray of hope that it might be possible to detect a planet came with the discovery by Dave Latham and Svi Mazet of a mysterious object orbiting the star HD 114762.
They announced the detection of an object that they called a brown dwarf. They looked and they didn't see it in a telescope, so if it was a star, if it was 1,000 times the mass of Jupiter, they would have seen it.
To this day, it is not known whether this object is a planet, a brown dwarf, or even a low-mass star, but its discovery emboldened others to continue the search. A different and dangerous approach to planet hunting was underway in Canada. The team of Gordon Walker and Bruce Campbell employed the deadly gas hydrogen fluoride in an attempt to precisely measure Doppler shifts.
And would be in there doing the setup, and the other person would be outside of the room looking through a porthole with 2 gas masks. And his job was, if something went wrong, throw on a gas mask, run into the room, throw the gas mask on the other guy, and drag him the hell out. Any good science should have an element of danger. There should always be at least the vague hint of death involved. Otherwise, you're not really on the cutting edge. They really pioneered the whole field, just a spectacular achievement.
We're all here because of the work that they did.
In In 1992, another incredible discovery piqued the interest of astronomers looking for exoplanets. But these new exoplanets were not orbiting a regular star. They were orbiting a pulsar.
Two very small bodies got detected at Arecibo by Wilson and his colleagues, and they really got us scratching our heads. So we call them pulsar planets.
The formation of planets is an incredibly robust process, and that's what that discovery told us, and we missed it because we didn't understand it.
We should have understood that planets don't come in ones, that they come in systems, but we were still
Halfway around, and they used it to turn their eyes on exoplanets.
My first day of work, I got this booklet from Michel that was the ultimate knowledge of data processing of spectroscopy. There was almost nothing at that time, and that's it. And we had to do this instrument, and we designed this practically without much support from anybody else because the other people felt that this was not interesting.
After a few months, already at the end of '94, we got a signal of variability for several stars, not only one, several stars.
We realized very rapidly that the instrument could be far more precise than we thought. So I started with a couple of stars a bit more intensively, and 51 Peg was one of them because it was bright. And very rapidly, 51 Peg had a very weird behavior.
On one side, we were absolutely sure of the quality of our measurement. All the signal was in favor of a planet, but it's evident it was a so unusual planet.
And I really felt at that time, there is something really bad in the software on the instruments, and I better to figure out because otherwise my PhD would be compromised.
Over the next several months, the two astronomers checked and rechecked their data. The problem was no one could imagine a giant planet with such a short orbit.
So we came back in July, this time together with Michel, very excited. Say, okay, let's see whether the conclusion that we had with the first bunch of data we had still holds.
The real moment where we had the confirmation of the reality of 51 Peg was really a planet, was in July '95.
First data on it, we say, okay, just luck. second data, still on the curve, we say, okay, well, 2 is fine, but still 2 is not enough. The third one, we're still on it, following a track, and then we say, well, let's just wait the fourth to be really, really sure, because it was so embarrassing conclusion, the planet, that we really want to make sure that was real.
We got the good period, the good amplitude, and so on. So at the time was really the time for the celebration. Before we were not sure that it was a planet.
There is a real planet, believe it or not. There is no theory to predict that planet, but there is a planet.
Following days of rumors circling the globe, at a conference in Florence, Italy, the news unofficially leaked. A Jupiter-sized planet had been discovered. This massive planet was making a complete orbit of its star in only 4 days. How could that be?
Suddenly there's this 51 Peg, which is a Jupiter-sized planet, but in a 4-day orbit. And people knew that was impossible. Jupiter-like planets orbited like Jupiter and Saturn orbital distances.
Back in San Francisco, Marcy and Butler, by mere coincidence, had 4 consecutive days of reserved telescope time at the Lick Observatory, the exact amount of time needed to confirm or debunk the claim.
We hit the star very hard for those 4 nights. We reduced the data as quickly as we can. We were blown away. We saw exactly the signal that Mayor and Clough had announced.
Confirming my data, to me, was just the best gift I could have had, because I said, oh, fine. So all the work I did is...
Welcome to Space to Ground. I am Catherine Clayton. This week we're highlighting the contributions of students from across the nation and a set of upcoming spacewalks. Sending supplies to the International Space Station requires a different packing method than the luggage we use to travel on Earth. Special flight lockers are used to transport supplies from Earth to the International Space Station. 4 of these lockers launched on the SpaceX Demo 2 flight to the station. The lockers are built by students from around the country through a program called NASA Hunch, or High School Students United with NASA to Create Hardware. Hunch provides students an opportunity to play an active role in the space program. Students in on the station. On June 26th and July 1st, the astronauts will begin the replacement of batteries for one of the power channels on the ISS. The astronauts will replace aging nickel-hydrogen batteries on one of the power channels on the far starboard truss